This is section 9.6 and 9.5. First, we're going to take a look at section 9.6, solving rational equations. When we're solving rational equations, the way that we're going to eliminate our fractions, and that's what our goal on all of these is going to be, we're going to multiply each fraction by the least common denominator, or LCD. And you guys are familiar with that from section 9.2. So let's go ahead and take a look at number 1. We want to figure out what is that least common denominator. Well, we have x plus 3, which we know we'll have to include because that is a factor on its own. And then we also have 6 and we have 18. Now because 6 goes into 18, I can go ahead and say that 18 is going to be part of that least common denominator, because if I plug that 18 in, it's going to take care of the 18, and it's also going to take care of the 6. So we want to multiply each of our three pieces of this equation by x plus 3 over 18. Alright, and so now we can see what is that going to do to each piece of our equation. And for our first equation, we have 4 times x plus 3 times 18. Well, there's also an x plus 3 on the bottom, so that x plus 3 on top and that x plus 3 on the bottom are going to cancel. And we're just going to be left with 4 times 18, and there's not going to be a denominator anymore. Same thing with the 5 over the 6. We're going to multiply by x plus 3 and 18, and our 6 and our 18 are going to reduce. So now on the top, all I'm going to have is 5 times x plus 3 times 3, because that 18 got reduced. And then for the third section, also multiplying it by the x plus 3 and the 18, the 18s are going to totally cancel out, so that we're just left with 23 times x plus 3. So now we can go ahead and simplify this. So first, we're going to have 4 times 18, which is going to give us 72. And then we have 5 times 3, which is 15. And that's going to be multiplied with x plus 3. And then we have 23 times x plus 3, so I can distribute here. And I end up with 23x plus 69. And then I can distribute again with my 15, so that I have 72 plus 15x plus 45 equals 23x plus 69. I can combine like terms on the left-hand side so that I have 72 plus 45, which gives me 117, plus 15x equals 23x plus 69. And then I'm just going to get my x's on one side and my numbers on the other. So we have 117 minus 69, and that gives us 48. And then we have 23x minus 15x, and that's going to give us 8x. And then we're going to go ahead and divide both sides by 8. And we're going to have 48 divided by 8, which gives me 6 as my final answer. And I'm actually going to do 2, 3, and 4 on separate slides, since these are going to take up a lot of room. Alright, so let's go ahead and take a look at number 2. We have 2 over x plus 3 over 2 equals 19 over 10. So we know when we're talking about the least common denominator, we're definitely going to be using that x plus 3. And then when we look at 2 and 10, we know that 2 goes into 10, so we know that if we include 10, it's going to also take care of that too. So usually the rule of thumb is going to be you want to look at the bigger number, and if the smaller number goes into that bigger number, then you just want to use that bigger number as a piece of your least common denominator. So now we're going to multiply each of these pieces of the problem by x plus 3 times 10. And I'm going to rewrite the problem so you can see a little bit better what I'm doing. So we have the problem 2 over x plus 3 plus 3 over 2 equals 19 over 10. And I left the space there on purpose so you can have a better idea of what's going on with this problem. So since we found the least common denominator of x plus 3 times 10, we're going to multiply each of these by x plus 3 times 10. And now the whole reason that we do that is because that's going to get rid of my denominators for me. So now we're going to go through and get rid of those denominators. My x plus 3's are going to cancel on the first one so that I just have 2 times 10, which gives me 20, plus on the second one, we're going to have our 2 and our 10. Our 2 will cancel, our 10 will turn into a 5 because 10 divided by 2 is 5. So then we have 5 times 3, which is 15, and then we still have that x plus 3 on this one, equals, on the last piece, our 10's are going to cancel, so we're left with 19 times x plus 3. So really, finding that least common denominator and actually getting your things to cancel, that's really the only new thing. From there on out, it's just distributing and combining like terms and then getting your x by itself. So let's go ahead and finish this one out. We're going to distribute the 15 so that we have 20 plus 15x plus 45 equals, we're also going to distribute the 19. So 19 times x is just 19x. And then we have 9 times 3, which gives me 57. Now I'm going to combine like terms on the left, so 45 plus 20 is 65 plus 15x equals 19x plus 57. I'm going to move my x's over to one side, and I'm going to move my numbers over to the other side. So we have 65 minus 57, which gives us 8. And then you have 19 minus 15x, which gives me 4x. I'm going to divide both sides by 4, so x equals 2 for my final answer. Let's go ahead and take a look at number 3. We know by looking at this we would have to come up with our least common denominator, and we know that x minus 4 is going to be included. And then we have 48 and we have 12. So remember that little trick I taught you. Go ahead and look for the bigger number, and the bigger number is 48. And does 12 go into 48? Yes, it does. So we know that our least common denominator is going to be x minus 4 times 48. Again, I'm going to go ahead and rewrite the problem out so that it's bigger and you can see what I'm actually doing here. So we have 7 over 12 plus 9 over x minus 4 equals 55 over 48. So now that we have our least common denominator, we want to multiply each piece by that. So we have x minus 4 times 48. X minus 4 times 48. And x minus 4 times 48. So now we want to go through and we want to simplify. On the first piece, 48 and 12 simplify to just plain old 4. So we end up with 7 times 4 times x minus 4. So I'm just writing what I have left. So I have a 7, an x minus 4, and a 4 left, so I have to include those. Plus, on our second piece, we see that the x minus 4's cancel, so I'm left with 9 times 48 equals, then on the last piece we see that the 48's cancel, so I'm left with 55 times x minus 4. So now I can go ahead and simplify here. On the first piece I have 7 times 4, which gives me 28 times x minus 4, plus 9 times 48 is going to give me 432 equals 55x, and then we have 55 times negative 4, which gives me negative 220. Again, I'm going to distribute the 28. So I have 28x, and then I have 28 times 4, which gives me 112, plus 432 equals 55x minus 220. Now I'm going to get my x's to one side by subtracting 28x. I'm going to get my numbers to the other side by adding 220. So on the left-hand side, I have 112 plus 432 plus 220. And on the right, I have 55x minus 28x. So 112 plus 432 plus 220 is going to give me 764. And then 55x minus 28x is going to give me 27x. And then I'm just going to divide both sides by that 27 to get the x by itself. So 764 divided by 27 is actually going to give me a decimal. So we end up with 28.30 approximately. And our last example of one of these. So we have 2x over 3 plus 4 over x equals 3x plus 1. So in this case, looking for that least common denominator, we know we have to include the x. And we also know that we need to include a 3. And in this case, there's only one number, so it makes it really easy for us. So now I'm going to go ahead and write this out so you can see what I'm doing. So we had 2x over 3 plus 4 over x equals 3x plus 1 over 3. So we have our least common denominator. There, we're going to multiply everything by. So x times 3 on each of these. And now we're going to go ahead and do some canceling. So on the first piece, we see that our 3's will cancel. So we're going to have 2x times x plus, on the second one, we'll see that our x's cancel. So we have 4 times 3 equals, on the last one, our 3's will cancel. So we have 3x plus 1 times x. So 2x times x is going to be 2x squared. 4 times 3 is going to give us 12. And then here we have to distribute on the right-hand side, so we end up with 3x squared plus x. So this one's a little bit different because we're dealing with squareds and x's. So we can go ahead and get everything over to one side to see if we can do maybe some factoring. So I'm going to subtract 2x squared. I'm going to subtract 12. So that's going to give me x squared plus x minus 12 equals 0. And so let's go ahead and think about this. Can we factor this? And if we use big X to factor this, we're going to end up with x plus 4 and x minus 3 equals 0. And then we're just going to set both of those equal to 0. So we end up with x equals negative 4 and x equals 3 for our final answer. Now let's go ahead and take a look at 9.5, variation functions. So we've got 3 examples here that we want to look at. And these are actually pretty simple once you understand the wording. You've actually done problems like this before. It's just that you have to understand what the wording means. So in example 1, it says if y varies directly as x. So what I'm going to have you do, I'm going to go ahead and have you write a proportion. So it says that y varies directly with x. So we're going to say y over x. Okay, now it's going to give us some information. It says y equals 15 when x equals negative 5. So that's going to be our first proportion that we're actually using. And this over here is just our guide. That's telling us that y is always going to be on top. So 15's on top, and that x is always going to be on the bottom. So negative 5 on the bottom. And then it says to find y, so that means we're not really knowing what y is. We're going to leave y when x equals 7. So we're going to plug in 7. So now this should look really familiar to you. All we have to do is cross multiply and divide here. So I'm going to have 15 times 7 and negative 5 times y. So I'm going to end up with 105 equals negative 5y. And I can divide both sides by negative 5. And that's going to give me my final answer of y equals negative 21. In example 2, the wording is slightly different, but it's going to be the same type of problem. It says, suppose y, and I'm going to write a little guiding section over here for us again to help us out. So suppose y varies jointly as x and z. All that means is that x and z are going to go on the bottom. So this is our guide right here. It says to find y, which means we don't know what y is. Find y when x equals 9 and z equals 2, okay? If y equals 20 when z equals 3 and x equals 5. So again, we have a proportion. We'll do a little bit of simplifying here. So we have y over 18 equals 20 over 15. And then we're going to just go ahead and cross multiply. So we end up with 15y equals 20 times 18 is going to give us 360. And then we're going to divide both sides by 15. So 360 divided by 15 is going to give me y equals 24 for our final answer. And then on example 3, it says if A varies inversely as B. So what this means, it means that A over B is going to be equal to B2 over A2. So we're kind of going to be flipping the second one. So it says if A varies inversely as B and A equals 28 when B equals -2. So we're going to go ahead, still using this as our guiding force. We have A is 28 when B is -2. Find A. Now keep in mind that the new A for the second piece is going to be on the bottom. So A is going to be on the bottom here when B equals -10. Okay, so now same type of thing. We're going to cross multiply. We have -10 times -2, which is 20. And we have 28 times A, which is 28A. We'll divide both sides by 28. And 20 over 28 is going to give us a decimal, or in fraction form, A is going to equal 5/7 in this case.